I'm Patrick Bailey with iQlist.com. Today is February 26, 2019, and in this video I'm going to show you how to create a thought bubble in Openscad with some text in it. Now, some of you out there may not be familiar with Openscad. Now, in my opinion, it's probably one of the three, it's one of the three design tools you should be aware of or use. Definitely be aware of if you're doing 3D printing. The other two being Fusion 360 and, to a lesser extent, Tinkercad, which is really good for younger kids or for some simple things. But Openscad is design as code. And so you can write code that designs stuff. So let me give you a few examples here. So you can go to openscad.org. And from here, you can actually go download the program. It's open source. It's free. You can download it for Windows or Mac or even Linux. Then also, another thing you probably want here is a cheat sheet. Here's a cheat sheet that shows some stuff. I'm not going to go over everything here, but there's a lot of examples that you can do. But I've already downloaded it. I will go here and open a new one. I'll just say new. And you can do some cool stuff in here. So I can come down here and say circle. Circle diameter equals 19. And a semicolon to close it. So this is a code. And then if I come up here, I can do a preview, which is a fast run, or I can do a render, which is a much slower run, but is more accurate. And sometimes you have to do a render. And so there is a little circle. But there's a preview. There we go. So the preview, yeah, okay, that's why I did it. The preview gave it a three-dimensional. This is flat. This one is not doing that. So there we go. So there's a circle. And then from here, now you can start doing other things, like you can extrude it. So I'll do a linear extrude. And I'll say for, it is unitless, just like, STL files unitless. But basically, 4 means 4 millimeters when you, at least for me, when I'm using my Prusa and STL file. So I'll go with that. So here, I'm going to say, hey, make this circle of diameter 19. And linear extrude it 4 millimeters. So it'll be 4 millimeters high. And boom, there you go. You can do all kinds of cool things like that. You can also come in here and you can set, what do they call this? But basically, how many sides, how much detail you're going to have. And so I can come down here and I can say 10 if I want to do things quickly. And you can see it kind of made it a little blocky there just for convenience. Or I can do 100 and I get a lot more detail. So you can change that as you're doing code, which I do a lot. Let's see. And then when you're all done, so I'll just, I'll make it 10. So I'll make it 10. I'll give it 11 sides. And then I can save it as an STL file. So now it's done. I can save an STL file. I'll just put it on my desktop and call it test cylinder. Boom. And now I can drag and drop that into Prusa control, just like any other STL file. Come on, work with me. There we go. And I can just drag that in, and there's my file. And you can see there it is, about the size we said, 10 millimeters high, 19 millimeters across. So cool. You can do design as code, and you can do functions in there, methods in there, variables in there. So if you're a coder, it's somewhat limited, but you can do a lot of stuff. You can do functions, you can do real cool stuff. I'm not going to get into functions in this, but I'm going to do just programming. I'm going to program through the whole thing just sequentially. And in the end, I want to get something like this thought bubble, but in 3 dimensions. And I also want to put a voided space in there so I can actually put a magnet in there. But with that, let me get going on how to do that. Okay, so I'm going to walk you through this. Now, there are some variables in here, so I can change the width and the height of this. This right side, I can flip this little thought angle from one side to the other. I can change the border thickness. I can change what's in there. I can change the font size. So if all you care is you want to go use this and do this, and you don't care about learning this probably, well, I'll put this thing on Thingiverse, and I'll put a link in the show notes, and I'll probably show it at the end here. So if you just want to go grab this and test it out, go grab it. But if you want to learn something about Fusion 360, if you want to learn something about Openscad, follow along, and this is where our end goal is going to get. We're going to get something like this. That is variable, so you can change the font, you can change the text in there. So with that, let me pull this blank slate in here. So I will run this, and I have nothing. Well, nothing now. So first, let me get that oval shape going. So I'll come in here and start off, and I'll put that detail at 50 for the starting. That's a good start. And so I'm going to say, I'm going to put some variables in here, a width of 80. So in my case, it's going to be 80 millimeters wide, and a height of 35 millimeters. And so that's what I want my oval to be. And so now I can use those numbers in my equation. Now, currently, at least I couldn't find one, there is no ellipse function inside of this, inside of Openscad, but you can do a circle, and then you can scale it. You can elongate it one side more than the other, and you can get the results you want. So let's first do a circle, and I'll say diameter equals width, and now it's pulling that width of 80 into here as a variable, and there I can run. It's a 2D, and so if I come down here and I go, rather than do 100, I do 180, you'll see it gets bigger. So we can change things. That's the cool part. So I'll come in here and I want to scale it. So there's a tool called scale, a function called scale. And a lot of these tools, I like to put parens. So I like to put a paren because I'm a programmer, and so I like having things all organized and functional. And so what this is gonna, you'll see this through a lot. So I can have something that I'm going to apply to it. Let me see what they functions. Let's see that one. Scale transformation. So there's all these transformations, and so I'm going to apply these transformations to it. And what if I'm putting these parens in, it's going to apply to everything within here. So if I had multiple circles, it's going to apply, or multiple squares, or whatever I put in here, it's going to apply to everything within these two parens. So I'm going to say, and so I can say 1.0, 1.0, and yeah, just XY. So if I do that, I've effectively done nothing. But I can come down here and say 2.0. And I've elongated it, so I made that one wider. That's not what I want to do in this case, but in my case, I want to do 1.0 and 1.0, 1.0 times height divided by width. That's where you get all this power. You can start doing equations, you can start doing math, you can have fewer variables, and boom. So there, I got my oval. Now, next thing I want to do is I want to get that little pointy end over here. So I'm going to come in here and say, I'm going to put a variable in here called right side equals true. And so that means if I make it false, I'm going to try to make this come on the right side. If I make it false, I want it to be on the left side. So I'll leave that here, and I'll come down here and say if right side. So it's going to say, hey, if this is true, I'm going to do something in here. And as an example, they have an echo function. So I'm going to echo test me. It'll output some text over here in this console section. So I'll run this, and I can see, there it is, echo test me. So that came out. So if I do false, I shouldn't get that. And I don't. So perfect. So I'll put it back to true, and I'll say, so I'm going to write, I did a little testing back and forth to get this right. I'm going to make a polygon. And polygon, I just have as many points as you have, kind of like on a path, and it connects them all. Another function they have. And so I can say 0, 0. This isn't actually what I wrote, but I'll say 10, 10. And for the third one, I'll say 40, 13. I don't know. And then semicolon at the end. I think that should, oh, something like that. Well, I'll just do what I actually did. Probably because I do 0, 13. How about that? It's probably being obscured. Here I can comment out the circle so I can work on this one. And you are not going to work. Okay, well, I'll just put in what I put in before. Okay, so you have 0, 0, and I have width times 0.35, and then a 0. And as a third point, I have width times 0.4 minus 0.4 negative height times 0.6. See what that gives us. And you don't like what you did. Oh. That's what I did. Sorry, this need another bracket to enclose the whole thing. There we go. That's what I was doing wrong. So you can play with this, and so I could make this one, 10. See how it moves at? So this is 0, and that's 10 up in that plane, in that direction. So there we go. I'll bring back the circle so I can see it. Boom. There I go. I got that. But now I need the other side, which is going to be, if that happens to be false, so if it's on the right side, do this. Else, if that's false, now do this other thing, which is going to be the other side. And so I'll do a polygon. This time I'll do multiple brackets, right? All right, so I can do 0, 0, 0, -10, -10, 0. And I'll say false this time. And so now, I might not be able to see it because that's being obscured. I get a little shape. But now let me fix it to what I truly did, which would be 0, 0, and then I'm just reversing stuff. So negative width times 0.35 and a 0. Now here you can see me putting these on multiple lines. They don't have to be on multiple lines. They can all be on one line. I'm just doing that for the convenience so I can read it. Minus width times 0.4 minus height times 0.6. Let's see if that's right. There we go. Bring back the circle. Boom. So now it's on that side. So a nice thing is if you want it to be the thought bubble to be on the other side, all you got to do is change this variable from true to false or false to true. Other side, right? And I could go false. Other side. So back and forth, however you want. Let me fix it to this side. So there we go. We got that working for us. So now, next thing, we want to extrude it. So I want to bring it up. And I want to do this multiple ways. So the first time, I'm going to make this whole thing about 10 millimeters, and I want to make it a magnet. And I found as I make some of these magnets, that one's a little bit bigger, but 10 millimeters is a pretty good height. But you want to save about 2 or 3 millimeters for the bottom, because I want to angle it in. Otherwise, it's too flat and you got nothing to grab. So I kind of want a little 45-degree angle at the bottom. So I'm going to do that in 2 parts. So the first part, I'm just going to go up 8, and I'm going to go down 2 and angle in. So what I can do is I can use a transformation. I'd use that linear extrude. And so I can come in here and say linear extrude. And I'll make it 8, which it's unitless, but in my case that translates to 8 millimeters. And that'll work, but I like to go back here and clean up things. Just adding 2 spaces to everything so it's nicely enclosed. And towards the end, I'm going to get too much in here, so I'm probably not going to do that all the time. And you don't have to do that. So let me run that, and boom, we're extruded. So far, so good. So now let me go to the next part here, where I'm going to do the lower section with the angle. Okay, the lower section. So this is a fun one. So what I'm going to do here is I can use this to comment out. So a slash and a shift 8, the star, is a way to comment a bunch of stuff out, and then slash, begin. And this comments this whole section out, so it won't run it. And so right now it says, even though you see it, it's basically didn't run because it doesn't see anything to put there. So now I'm going to make the lower section, which gets a little bit fun. So what I need to do, and for you programmers out there, yeah, you can put functions in here and make your life easy, but I'm just going to be a little redundant here. So I'm going to come back here and scale and do this. Now if I run that, it worked. That gets that. But what am I doing? This is why. This is why. Because you can't go down. Now you can do an extrude. You can do an extrude where you scale. So let me do that right now. You can scale. So I'll do a linear. Okay, I'll do a linear extrude. just like I did before, and I'll say height equals 2, and I'll say scale. I'll just do height equals 2. Come down here and that, which is effectively what we did before. It just has a height of 2 versus 8, and so that works. But what does not work is I cannot go negative. It just won't allow me to do it. So there's a couple ways to solve this problem. So one way is to actually let it go up 2 and then do a mirror. So you can let it go up 2, and then you can kind of put a virtual mirror in the plane and have it go down. So first of all, let me go up 2, because I have to go up to 2. And as I go up, I'm going to scale it. So I can do scale up. The linear extrude allows some scaling, so I'll say scale equals 0.9. I think that worked for me. There you go. Not perfect, but good enough for what I want to do. It gives me a little edge I want. There are some other possibly more precise ways to do that, but it works. But it's on the wrong side. So now I need to mirror it. So I can say mirror. And you got your planes X, Y, and Z. So X I don't care, Y I don't care, but Z I want to mirror that plane. And I come down here and close that parentheses. And again, I don't have to put spaces in here, but I do. I don't think there's a nice way to quickly edit that in this tool. Okay. Now I run it, and it reversed it. So it's mirrored on the other side. And now let me bring this guy back. Boom. And there I go. So I got that. I got the mirror on the back, and it's good. All is good. Okay. So the next thing I want to do is I want to make that border on the top. So what you can do is you can subtract shapes from other shapes. So this gets a little more complicated. Let's see. So first we'll put in test here. So we're going to want to make this other one subtract from that one. Fun. Let me comment this whole thing out, because otherwise it's going to get a little confusing as we do some of this simpler stuff, just to explain what's going on. So here I'll do I'll just copy and paste my notes over here. Boom. Let's run that. There we go. So here I'm doing just a simple linear extrusion. I've got my, why did I do a circle? I guess I just did a circle. Why did I make those notes? You wonder why you make notes sometimes, right? That's just that. Linear extrude. Don't know why I did those notes. Let me delete that. Why would I write that? Well, anyway, I'll go on to this one. Boom, 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 boom. Oh, yeesh. We'll just do the whole thing. Okay, so what we're gonna, we'll come back here. Okay, we'll undelete this. And so what we're gonna have to do is you can do unions and subtraction. So we'll re-render what we had before, and so we want to pull out a space in between. So the first thing we'll do is we're going to have to do a union. So even though those are next to each other, they're not part of the same object. So you actually have to make them part of this, put them together. So now they're considered one object, so we can subtract stuff from them more easily. And then what we're going to do is we can do a subtraction. But before we do that, we'll come down and actually, oh yeah, I should just probably paste my nerd stuff. Okay, so I'll come down here, and I'll just make an object. So I'll say circle d equals, width divided by, and we'll just do a number. We'll just do d equals 30, and we'll do a linear extrude of that circle. Linear extrude, we'll just say 20. Now if we run that, we'll see Did not like that. Oh, because I can't spell circle. There we go. So there's this circle sticking out. And let's say we want to subtract that space. So this whole thing's an object. This is an object. We can come up here to the very top and say subtract. And this is the point where I'm not putting spaces in. So this is going to say, make sure I do this right. Not subtract, difference. Difference. This is going to say this object is the main object. The next object or following objects, you have several objects, will be subtracted from this object. And this is the next object. And I'll end that subtraction. And so now I should have a gap. There we go. Now it doesn't go all the way through because this circle actually started at the 0 point, and there's that bottom point that we mirrored and flipped. So that's actually still there. So that's kind of cool. But now that we know that, now let's go fix it. Okay, because what we really want to do is I want to recreate this thought bubble just slightly smaller in such a way that the edge of that is the same all around, and I want it to go down to effectively be placed 2 millimeters below the surface and subtract that, so I have this little space where I get a border. And so to do that, you got to do a lot of math, which I did. So you don't need to do that. Border equals 4. So there's my border. It's a variable now. I'm going to reuse that border. And here, let me cut and paste my math nerd stuff. So you come down here. And lots of geometry. Not all that difficult, but just, I'm not going to explain that all to you. That's just a lot of a squared plus b squared and cosines and arctangents and all that stuff to figure stuff out, how to shrink things properly so that we can get that edge properly done. And then what we're going to do, do a little cutting and pasting here. So now this is going to be the object we create. I can cut and paste. Boom. So here is our circle, and we had to do a little bit of changes based on that border. So that border is going to change the width and all that stuff of it, so it's going to be smaller. So as a result, this should show up and remove that cavity we want to do. Also, we're going to do, another thing, I'm doing an extrude 10 millimeters high. I don't have to go that high, but also before that I'm doing a translate. I can move things in space. In fact, let me comment out the subtraction. Coming out that the difference. I'll come down here to the union. I'll remove this whole first thing. Just run this piece that we're going to subtract. Here's the piece we're going to subtract, and you can see it's floating above. It's actually above the plane. That's where it started, and we can do that because we use this translate, which says start 6 millimeters above. So I moved this whole thing 6 millimeters above. Bring it all back. Oh, I need difference. There we go. Bring that back. There we go. So now, there we go. I got the start of the thought bubble. And I can, hopefully if I've done this correctly, I can change it to false. There's an issue here. Yeah, this is the part of the code where I didn't quite do this false part right, and I'm not doing this equation quite correctly. Let me see if I can go find my fix and just copy it. There. Boom. There we go, fixed. So now it looks a little bit more right. Okay. Boom, 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 boom. Next thing I'm going to do is add in some text. So you want to do a couple of things in here. So I'll come in down here and I'll say message. Message, this is what is going to be the text in the text. And say drop. I'm going to say drop mic. It's kind of what I felt like when I finally got this done last night. And then a font size. I put it up here at the top so it's more easy for everyone else to change and fix. Now this font size, you may have to adjust based on the font you're using and the space you're using because, speaking of which, see, I can come in here and rather than being 80, I can say 120 and 45. And it should adjust accordingly. And all the math should be pretty good, so I have that border, and I can say, no, I want a border of 10, and it should adjust. Okay. Let me undo that. Okay. Now for the font, I'll put this note in here. You can change your font. So there's a default font it's probably choosing, but I put a note in here. You can change the font. These are the fonts on your computer, so they might be different than what's on my computer. So to change this, use the different font from menu, click the help font list. Change this. To change it. How about I change that? To change this. To change this. To change this. To use different fonts. Black and white. Go to the menu and click on the help. So you go up here and say help font list. And this will find all the fonts on your system. And so I'm using this Bauhaus. Let's see, I can probably do a search. Let's see, BAU, there it is. I can click on that. So there's Bauhaus regular. I can copy this information to the clipboard. Copy the clipboard, hit OK. And that should copy that information. That's what it wants. So I will switch the font here at some point, but for right now, I'll leave that like that. Okay, now font. So we can come down here, and the font is going to stick above. I want the font to come out right here and go no higher than 8 millimeters. So I can come down here, and there's a thing called text. So I can say text, message, that's the message we put in there, size equals font size, and Align equals center, H-align, I'm trying to get in the center here, equals center, and font equals my font variable. Now if I run that, you probably won't see anything because I forgot to put a quote there. No, I didn't. So H-align, what did I forget? Message, size, font size, align, center, H-align. Go right there. There you go. Oh, there's a drop mic. I must have messed something else up. So there's my text. What did I break? Just decided to stop for some reason. But that text, I do need to extrude it. So I can do a linear extrude. And I'll do 8 millimeters. That's what I want to bring up. It's not really millimeters, but 8. And so that should bring that up. There we go. Boom, boom. And you're being too big there. Oh, because I'm 120. 120 and 40. Cool. Okay, so next let me fiddle with the font some more and maybe do some rendering. Okay, let me change this font here to something else just to show that you can. Go back to here to help, font list. I don't know, choose something. Comic Sans, right? Copy to clipboard, hit OK. And then here, paste that in. Oh, I guess they give you the quotes with it. Okay, paste that in. Now render it. And we should see a different font style come through. There you go, different font style. So choose the font style you want. That works for you. But I'm going to go back to that one because I like that one. There we go. And my daughter pointed out this is not a thought bubble. This is a speech bubble.
Yeah, it's a speech bubble.
Because a thought bubble would have little circles going off. So.
And it would be a cloud.
And it would be more cloudy.
It would be like a cloud 2 dots, maybe 3 dots coming from it.
Isn't it bad when I used to be a comic book geek eons ago, and my daughter is correcting me on thought bubbles and speech bubbles.
And it's bad when you make half a video saying this is the thought bubble and it's a speech bubble.
Anyway, if you didn't hear that, she said it's pretty bad if you made half a video and you said it's a thought bubble and it's a speech bubble. But I'm going to keep calling it a thought bubble just for consistency's sake, right? Okay, so last thing I want to do is I've been doing magnets recently, but I need to add a void in there so I can put the magnet in. So I'm going to come in here and add a void, which means I need to make another, I need to subtract something from the end. So I already have the union, which is fine. I come down here where I have the difference. And this union is that first part, and this is that second part being removed. I can put something third here that would be removed as well. It'll keep removing things that are within there. So I will I'll do a little copying and pasting but we're gonna have an issue. So I'll do a little copying and pasting. This thing happens to have this magnet has a diameter of 31.5. It has a thickness of 2, but I'm doing 2.2 to give a little bit of wiggle room. And I want it to be a depth of 0.8 from the bottom. And the bottom actually starts 2 below. So here I had to translate, go -2. So I go -2, and then plus that 0.8, that depth, and that's where I start from. And then I draw it, and that should get me my result. So now I'll render it. And I failed. Why'd you fail? Oh, because I add an extraneous one. Well, there we go. Okay, now I'll save this as an STL file. I'll go to, let's see, sequence. Speech bubble. Thought bubble sounds cooler, but you're right. Dang it. I'll call this test. There we go. Test. Replace it. So we'll bring this guy back over here. Come on. Why are you stuck? Okay, prints, testing. There we go. And drag this guy in. Boom, there's my thought bubble. Speech bubble. Speech bubble. But there is a slight problem here. So if I generate this, there's a problem with that void. There's my void. But once I hit 2 millimeters, which would be kind of where the surface was, right? The 0 plane. There's my text. My text is going to show up in there. So there's a problem. A couple ways to fix that. I'm going to do the simplest way to fix it. I could put the text I could put this inside the union. Or I could translate this higher, knowing that that's going to be a full space anyway. So let's see, what did I do? Did I translate it higher? That's what I did. So I'll come in here and I'll say translate 006, which means I'm going to make that only 2. So 6 plus 2 is 8. I'll get the same results, and now I won't get that void. I won't get the text in that void that I want to make. So there we go. Save that. Okay. Well, I do want to save that code. Let's see if that's. I'll render that. Save the STL file. I'll call it test again. Yeah, replace it. And then we will drag that guy back in. And there you go. We'll generate it. And now that should fix my problem. Boom. There we go. Cool. Okay, so lastly, a couple things you can do is for my last one, I want to up this detail, so I'll probably put it like 150. Anything over 100 is probably overkill, but I'll overkill it. Probably put it at 200. But also you can lower kill it. So I can come down here and say 15, and it kind of sometimes might give you a low poly effect that you might like. 15 might be too low. There you go. See, I do 15, I kind of get this low poly effect. So I'm going to go do a 15 and probably 150, and I'm going to go print them both out. And part of what I'm going to do back here in, let me go generate. I need to put some switch points. So I'm going to come down here, and right there I'm going to put a switch point in, because at that point it'll stop at this layer. There'll be a cavity. I can put my magnet in, and then continue, and then at that point I put another switch point, because now I can change my color, and so I can have this all, like a, well, no, what am I gonna do? I'm gonna do another one. At that point I want to go back to whatever my color is going to be, but if I want a white surface there to show through, 1, 2, 3. Depends on what you want. So what I'll probably do is I'll do one solid color. I'm out of black right now for some reason, but I'll probably do red. So I'll do this solid red color at the bottom. It'll get up to here, and then I need a couple 3 layers of white. So it'll be white, 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 and then back to red is my plan. So I'll save this G code off, and let me go print it. Okay, a few things before I go over the numbers. So I did mess up my code a little bit. I didn't show this. I'd fixed it before, but I forgot to put it in while I was videoing this. So when I did this scale to kind of shrink it down at the bottom, it shrinks the center. And so it kind of messes up and doesn't shrink very well on that little angle part, because off center it kind of shrinks it at a skew. So what I had to do here, and this is kind of interesting thing you can do in Openscad, is if you look at this, here's where I draw one of the angles. There's 2, the left or the right. So I draw that, but before I do it, I translate it. So I move it kind of over to where it's a little center. It's in the center, and from there I do a linear extrude, and that's where I do the scale. So I actually move it to the center and scale it so I get a better angle on it, and then I move it back. So you can see this translates kind of the opposite. There's kind of cool things you can do with that in Openscad. But anyway, I wanted to show that. But this is the actual code that I've now posted on Thingiverse. Before I show that, let me go over the numbers. Oh, and an issue. It's an issue I think I can fix. So I actually printed out the low poly version, and I wasn't thinking that the low poly version also does a low poly circle in the middle. So it's more like an octagonal, and I can't fit my magnet in there. I can't squeeze it in there because it's hitting the edges. I think there might be a way around that, but that's for another video. So just to warn you, if you're doing something like that, it's not going to work unless you make that center bigger so that there's more than enough space to stick that magnet in, but then it's not going to be tight. But anyway, so the numbers. So to print this out, boom, it took 1 hour and 9 minutes to print out. It took 0.01 cents, so 1 cent worth of electricity, and it weighs 0.03 kilograms. So at $20 per kilogram for a roll of filament, that's 60 cents worth of filament. And so total cost, 61 cents to print that out. So not too bad. So I printed that one out. I did change my code up on Thingiverse, so now it just says customize this rather than drop mic. And I'm getting a little bit of grief from my family for this because they say it should be drop the mic drop, whatever. But hey, they're magnets. So hey, I got magnets in mine. A magnet. So that's cool. Okay, so lastly, I'll just show you. It's up here on Thingiverse. So it's on Thingiverse now. It's thing 3457772. So go feel free to check it out, download it, and change the text, change the font, do whatever you want. But anyway, it's kind of cool. So I hope this video was helpful, and I hope you learned something about Openscad. And if you don't know about it, go learn it, because there's a lot of cool things. There's a lot of ideas I have that I can do with Openscad. I got a lot of cool ideas. Openscad is just a really cool tool because you can do it as programming. And if you didn't know, in fact, I think all the Prusa parts from Prusa are in Openscad. And that way they can keep order of the changes. So if they make a tweak, they have it in a Git repository somewhere, so they can actually change. They can look at the history of all the changes and look at all the revisions and do little tweaks, and people know exactly what's going on. So, anyway, I like Openscad. I love Fusion 360 and I love Openscad. Both serve a little bit different purposes, but both are really good tools. So, anyway, hope this video was helpful to someone. Anyway, have fun. Hey, if you liked the video, give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we're doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.